Hi class, in lesson 8.2 we are going to be looking at simplifying algebraic expressions. Learning targets for today, we will use the associative and commutative properties of addition and multiplication to help us simplify expressions. We'll be looking back at using the order of operations, and we can also talk about looking at our colored pencils again to represent our algebra tiles in order to simplify algebraic expressions. Let's take a look at the problem situation for problem number 1 on page 540. It says that you and your friends are going bowling. It costs $2.50 to rent shoes, and it costs $3.50 to bowl one game. So to get started today, I want you to answer letters A, B, and C, and then number 2 says to describe how you calculated the total cost for each situation. Here are what your answers should look like for A, B, and C. For letter A, we should have $6 to rent shoes and bowl one game. For letter B, $9.50 to rent shoes and bowl two games. And for letter C, $13 to rent shoes and bowl three games. For number 2, you're going to multiply the number of games that you bowled by $3.50, and then you are going to add that $2.50 to the product for the cost to rent the shoes. Let's finish up page 540 by answering questions 3 through 6. For number 3, what are the variable quantities in this problem? Number 4, the constant quantities in the problem. Number 5, what variable quantity depends on the other variable quantity? And finally, for number 6, we're writing an algebraic expression to determine the total cost to rent shoes and bowl games. G is going to represent the unknown number of games bowled. Let's take a look at the answers for 3 through 6. For number 3, the variable quantities are the number of games bowled and the total cost to bowl the games. For number 4, the constant quantities are the cost to rent the shoes and the cost of each game. Number 5, the total cost of bowling depends on the number of games that you bowl. And finally, for number 6, the algebraic expression that we should have written down was 2.50 plus 3.50 times G. Let's take a look at the top of page 541. It says that there are several ways to write an algebraic expression to represent the total cost to rent shoes and bowl games. Let G represent the number of games bowled. So if we take a look at expression 1, 2, 3, and 4, you can see, like it says, that there are multiple ways. These expressions are equivalent because they express the same relationship. The commutative properties of addition and multiplication state that the order in which you add or multiply two or more numbers does not affect the sum or the product. The commutative property of addition states that changing the order of two or more terms in an addition problem does not change the sum. For any numbers A and B, A plus B is equal to B plus A. The commutative property of multiplication states that changing the order of two or more factors in a multiplication problem does not change the product. For any numbers A and B, A times B is equal to B times A. Expressions 1 and 3 demonstrate the commutative property of addition. These expressions are equivalent even though the order of the terms is reversed. Expressions 1 and 2 demonstrate the commutative property of multiplication. These expressions are equivalent even though the factors in the second terms are reversed. If we turn to page 542, it says when determining the total cost to rent shoes and bowl games, you use the order of operations. Recall that these rules ensure that the order in which numbers and operations are combined is the same for everyone. You should remember that when evaluating any expression, you must use the order of operations. So let's take a look at number 8. We need to evaluate each numerical expression using the order of operations and make sure that we show all of our work. So go ahead and do letters A through F. Here are your answers for letters A through F. A is 10, B 47, C 51, D 31, E 74, and F is 8. Let's turn to problem number 2 on page 543 and look at another property. Number 1 says to evaluate each numerical expression using the order of operations. So go ahead and answer each of those numerical expressions, evaluate them in the table that you see below. Answer number 2 and number 3 then as well. Compare the two expressions in each row. Tell me what you notice. And for number 3, how do the expressions in the first column compare to those that are in the second column? As you can see from the answers that you came up with in the table, for number 2, the expressions are both equal. You're going to get the same result for each of them in the first column and in the second column. All that has happened, if you look at the answer for number 3, is that the terms or the factors have been regrouped. The associative property of addition states that changing the grouping of the terms in an addition problem does not change the sum. For any numbers a, b, and c, the quantity of a plus b plus c is equal to a plus the quantity of b plus c. The associative property of multiplication states that changing the grouping of the factors in a multiplication problem does not change the product. For any numbers a, b, and c, the quantity of a times b times c is equal to a times the quantity of b times c. The commutative and associative properties of addition and multiplication are very powerful properties. For any expression involving only addition, they allow you to change the order of addends and to add parentheses wherever you want. For any expression only involving multiplication, you can also change the order of the factors and include parentheses whenever you want. So let's remember those key words. Whenever we are implementing the commutative property, we are changing the order, and whenever we are implementing the associative property, we are changing the grouping. Let's look at the top of page 544. Ben and Corinne are both trying to determine the sum of 22 plus 17 plus 3 plus 8. You can see that both methods are correct. They are shown there in the example. But I want you to take a look at the difference between their methods. Ben calculated the sum by adding each number in order, but Corinne used the associative property and she grouped the terms so that the calculations might be a little simpler to come up with. So think about implementing properties in order to make your whatever operation that it is that you're working with a little easier to do. Let's take a look at number 5. It says determine each sum by writing an equivalent numerical expression using the commutative or associative properties. If we look at our word bubble, it helps us to remember if we use properties, we can look for number combinations that are going to make it simpler to add, just like Corinne did. So go ahead and do letters A through D. Here is what letters A through D should look like if you implement the commutative and associative properties. For letter A, you can get 17, B is 20, C is 40, and D is 18. Let's take a look at problem 3 on page 545, simplifying algebraic expressions. The commutative and associative properties can help you simplify algebraic expressions. To simplify an expression is to use the rules of arithmetic and algebra to rewrite that expression with fewer terms. An expression is in simplest form if it contains the fewest terms possible, and if all like terms have been combined. In an algebraic expression, like terms are two or more terms that have the same variable raised to the same power. The numerical coefficients of like terms can be different. And we should remember all of these key terms, numerical coefficient, variable, and constant, from chapter 7. And in lesson 8.5, we talked about using our colored pencils to represent these different algebra tiles for x, y, and 1. So if we wanted to model the expression 3x plus 2 using our colored pencils, this is what it would look like. So let's take a look at number 1 on page 546. It says represent each algebraic expression using our colored pencils. We're going to get some more practice with sketching the models below each algebraic expression. Go ahead and do letters A through F. Here are what your models should look like for letters A through D. For A, we have 3x plus 2, B, 2x plus 1, C, 4y plus 3, and D, 5x. And here are your two sketches for letter E and letter F. E is just 4, and F is 2x plus 3y. If we take a look at number 2 at the top of page 547, use your models from question 1 to write each algebraic expression in simplest form by combining like terms. Remember that when you are combining your like terms, you are using your models to regroup all the same tiles together, or in this case, all of our colors that we use to represent the tiles. So go ahead and do letters A through F for number 2. For number 2, letter A, you should have 5x plus 3. Letter B, 3x plus 4y plus 5. C, 2x plus 4y plus 4. D, 4y plus 4y plus 7. E, 8x plus 2. And for letter F, 5x plus 4y plus 3. Homework for tonight is going to be number 3 at the bottom of page 547. I'd like you to simplify each algebraic expression for letters A through H. That's going to be it for lesson 8.2 on simplifying algebraic expressions. Please let me know if you have any questions.